This is lesson 3.2 from Unit 1, Transformation Information. This is actually the third part of this activity. This one is on just the rotation part, because I think that this is the most difficult part of the activity, to understand how to systematically rotate something 90 degrees in an organized way. So what you're supposed to do is rotate this image, A, B, and C, or rotate this figure 90 degrees around this center of rotation, which is point O. So you're going to go from this point, this position right here, and you're going to rotate this 90 degrees and end up here. So how do you do that? How do you go about figuring that out? And here it is rotated. And the reason I draw these circles is that I can keep track of the size of the image as I rotate it around. And so it makes it a nice way to size everything, position things as they rotate around that point O. So there's the figure, and the center of rotation is point O. So I'm going to draw the circles. They all have the same center. It's the center of rotation. It's around the point in which the figure is going to rotate. Fill it in. And the authors say, well, this is pretty easy to figure out a 90-degree rotation, because all you have to do is look at point C and realize that from this side right here, a 45-degree rotation gets you to this vertical line right here, and another 45-degree rotation gets you to this diagonal, and that together is going to be 90 degrees. So there you have it. It's a 90-degree rotation. So you just swing the figure around, and that is what it looks like. It's a 90-degree rotation. Well, how do you place these other points? Where do you know exactly where they go? Because it's not all that easy. You can count and try to figure it out, but you're not thinking about rotations if you're doing that. You're just thinking about the position of those points relative to point C. What I want you to do is think about rotations. How does B rotate to end up to here? How does A rotate to end up at this point? So the whole idea is to understand rotations. And there is a way to do this. It's a counting strategy that you can use to figure this out. So that's a 90-degree rotation. So I'm going to show you the x-axis and the y-axis. There's point A, and that's going to rotate to that point A down here, and that's going to be a 90-degree rotation. I'm going to prove that to you. So there's the rotation, and there's the lines figured in. So right now, you just kind of have to take my word for it. You can do some looking, some calculations, some counting, and figure it out. But let's go through it systematically. So we're going to use a counting strategy. Here it is all together. A is in the blue, B is in the green, and C is in the purple, but it's messy. It's hard to look at it all at one time. So let's look at these separately. So what I'm going to do is count the number of units from the center of rotation to get to A. So it is, in this case, 5 units. I'm not that concerned with the negative values and the positive values at this point. It's really just the distance from the center of rotation. So this is 5 units along the x-axis. 1, 2, 3, 4, 5. And it is 2 units in the direction of rotation. So that direction in this case is counterclockwise. So it's 5 units this way and 2 units this way. So now if you just swing this down here 90 degrees, how far is it away from the center of rotation? It's 5 units. So count 5 units. 1, 2, 3, 4, 5. And how many units is it in the direction of rotation? 1, 2. And so you place point A right there. So that's rotated from this point to this point. B is 3 units from the center of rotation and 3 units in the direction of rotation. So you have the center of rotation, the distance from the center, the point around which the image is rotating or the figure is rotating, and the direction of rotation. So now you just swing this around 90 degrees, It's 3 units from the center of rotation and 3 units in the direction of rotation. So this point B has also rotated 90 degrees. And here's C, 1 unit from the center, 1 unit in the direction, rotate 90 degrees, 1 unit from the center of rotation, 1 unit in the direction of rotation. So here are those lines connected to the center of rotation. This is A, this is B, and B and C are on the same line. So this is C. And B and C, once again, go back to this is going from one diagonal to the other diagonal. So it's pretty convincing that that is a 90-degree rotation. All right, so let's take another look at this. I'm going to talk about 5 and 2. So it's 5 units from the center of rotation and 2 units in the direction of the rotation. So it's 5 units out this way from the center along the x-axis, 2 units in the direction. So go 90 degrees, 5 units from the center, 2 units in the direction of the rotation. 5 units from the center, 2 units in the direction of the rotation. 5 units from the center of rotation, 2 units in the direction of rotation. So B, 3 units from the center, 3 units in the direction. 3 units in the center, from the center, 3 units in the direction. 3 units from the center, 3 units in the direction of rotation, and finally 3 units from the center and 3 units in the direction of rotation. And C, same thing, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, and 1 unit, 1 unit. Okay, so if we connect all the points and swing it around, it is 4 rotations gets you back to where you started. That means that each one of those rotations is 90 degrees, because 360 degrees divided by 4 is 90 degrees. So it has to be 4 90-degree rotations to get back to the beginning. All right, so let's just isolate point A. Let's just look at the rotation of point A. I know I'm going over this again and again and again, but it's worth it because this leads into some of the things that you're going to do later in the unit and for the rest of the school year where you're working in a coordinate grid. So again, I'm not that concerned with the labeling of the coordinates, although you're going to see a pattern as we look at this in more detail later on. This is 5 units along the x-axis, 2 units in the direction of rotation. 5 units along the y-axis, so here the 5 goes to the y value, 2 units in the direction of rotation. 5 units along the x-axis, so the 5 goes back to the x-axis, 2 units in the direction of rotation, and finally 5 units along the y-axis, so the 5 is on the y-axis, and 2 units in the direction of rotation. So if you put it together, there are 8 possible coordinates using 5s and 2s and using positives and negatives. So a task is to figure out when is it a 90-degree rotation and what are the other coordinates? What's this coordinate here? How is this related to the beginning corner of 5 and 2? And how do you form a 90-degree rotation when it's 2 along the x-axis and 5 along the y-axis? So this is 5 and 2, and this is 2 and 5. So again, the y-axis is 5 units, direction of rotation is 2 units. This is using different coordinates, 4 and 3. Again, 8 different combinations. And so you get the square, that's a 90-degree rotation, 4 and 3, to a negative 3 and 4. But then you have these values in between, these coordinates in between. So what are those? How are those related? And finally, good task would be to label each of these points. So if you begin here, what are the coordinates of that point? Can you predict what the coordinates of a 90-degree rotation are going to be once you know the coordinates of this point? In other words, can you predict what the coordinates of this point is going to be? Or if you want to go in a clockwise direction, can you predict what the coordinates of this point are going to be?